We are now on sigma notation. So the sigma notation will find sums where we'll be asked to just evaluate. Instruction mostly is to evaluate, then they give you a sigma. Then you are to know how to interpret this and what is expected of you when you find this kind of a sum. So now, on your sigma notation, the sigma, we can say the sigma present my sum. So now, as you found a sum that says evaluate, you now know that I am to find the sum using this formula, the TN formula, to firstly find the first three terms, and I'll start substituting 1 and I'll end at 10. So interpreting the sigma notation, you are to find the sum using the TN formula, start substituting from 1 and finish at 10. Then the first thing you are to know is that you must find the first three terms. You need to find the first three terms, which is your T1, T2, T3. So the first three terms that you'll find, they are the ones to tell you whether we are dealing with an arithmetic sequence or a geometric sequence. Since you have to find the sum, we only have the sum formula for an arithmetic sequence or a geometric sequence. So for now, we are just learning the interpretation of this whole thing, that you have to find the sum using this 10 formula to find the first three terms, substitute from 1, then you'll have to end at 10. Then you firstly find the first three terms, and those first three terms, they are the one to tell you whether it's an AR or a GS, so as for you choosing the correct formula. Then let's go to our first example. We are given, it's under sigma notation, evaluate the following. Then we find our sigma. At the top, we have a 10. We have a K is equals to a 1. Then here we'll have a TN formula, which is 5K minus a 4. So as I said, the first thing to do, you have to firstly find the first three terms of this sigma notation. So I'll use my TN formula, and where there's K, I'll take this one. For me to find my T1, T2, T3. So where there's T1, I'll have to use my 5. Where there's K, start put a 1 minus a 4. For my T2 is 5. Where there's K, I'll put a 2 minus a 4. For my T3 is a 5. Where there's K, I put a 3 minus a 4. Then 5 times 1, it's a 5 minus 4. I get a 1. So my T1 is 1. 5 times a 2, it's a 10 minus 4. I get a 6. 5 times 3 is 15 minus 4. I get 11. Now, I've found my first three terms, T1, T2, T3. They are the ones to determine whether I'm dealing with an arithmetic or a geometric. So if I am to use the common difference formula, which is T2 minus a T1 is equals to a T3 minus a T2. My T2 is a 6 minus a 1. My T3 is 11 minus a 6. 6 minus a 1, I get a 5. 11 minus a 6, I still get a 5. Therefore, I conclude my D, it's a 5. meaning that this is my arithmetic. So now I know that since I found my common difference, I'm now, the sigma I'm dealing with, it's a sigma where I'm supposed to find the sum of an arithmetic sequence. So now I go on to write my sum formula. 2a plus an n minus a 1 d. And now for me to find the n will determine whether I'm finding the sum of how many terms. I'll then go to my formula where it says my n, I'll have to use the top minus the bottom plus 1. Top, at the top of sigma I have a 10 minus the bottom I have a 1 plus a 1. 10 minus 1 it's a 9 plus 1 it's a 10. So the n I'm going to use, I'll go for the sum of 10 terms. So where there is n, I put a 10 all over 2. Then it's my 2. My first term, a, is 1, plus my n, it's a 10 minus a 1. My d, we found it to be a 5, close the bracket. You will then go on to punch this on your calculator as it is, and you be careful not to make mistakes. What you get is 235. So the sum of the first 10 terms, when I evaluate that sigma, it's 235. The sigma with the Distin formula, also r is the 7, then at the top you have a 15. So as I said, that you first have to find the first 3 terms. That's the first thing you do. So now it's saying where there is r, start substituting a 7. Then you must put a 7 where there is r to get your T1. Then it's T2. You must also get your T3. Then when you substitute a 7 here, okay, let's just go for negative 12. A 7 minus a 2 to the negative 2, you get your T1. Then you go on to substitute an 8 plus, where there is r, you must now put an 8 minus a 2. Then you go on to find your T3. It's now a 9 minus a 2 to the negative 2. Then my T1 is negative 22. My T2 is negative 24. My T3 is negative 26. Then after you have found your first 3 terms, the first 3 terms are to determine whether you are dealing with an arithmetic sequence or a geometric sequence. So from here, we go on to use the common difference formula, which is our T2 minus T1 is equals to a T3 minus T2. A T2 is negative 24 minus negative 22, it's equals to a T3 minus 26 minus a T2, a 24. Then this will get a negative 24 plus 22. This side is negative 26 plus a 24. This side will get a negative 2 is equals to a negative 2. Therefore, I conclude my D is equals to a negative 2. Now that I found my common difference, I can now conclude that I'm dealing with an arithmetic sequence. Then I'll have to write down an arithmetic sequence sum formula, which is our 2a plus and n minus 1 d. So to find my n, I still go on to use the formula. N is equals to the top minus bottom plus 1. I go back to my sigma. The top is 15 minus my bottom is 7 plus a 1. Then 15 minus a 7, I get a 13. A 13 plus 15 minus a 7 plus 1, you get a 9, meaning that your n for this sum formula, you're finding the sum of 9 times. When is n, we put a 9 over 2. Then a 2, my a is the first term of the sequence, which is negative 22, plus my n is a 9 minus a 1. Then my common difference, we found it to be a negative 2. Then you'll go on to punch this on your calculator as it is. Then your sum of the first 9 terms, it's negative 270. So that will be your answer. This is our third example. The third example, the only difference between this third example and the previous two sums we did is that now we are given that our sum for this sigma is 594. So we've already found the sum as 594. So the only thing that we are looking for is that what was n on our sum formula that will give us a sum of 594. So now we still have to firstly find the first three terms. The first three terms are to tell us whether we are dealing with an arithmetic sequence or a geometric sequence. So for us to find our T, T1, T2, and T3, we'll then substitute our K as 1 on our equation, which that will give us, if we substitute our K as 1 on our equation, will give us a negative 1. Then if we substitute our K as 2, we get our T2 as 3. We substitute our K as 3 on our equation, we get our T3 as 7. Then these are the first three terms which will determine for us whether we are dealing with an arithmetic sequence or a geometric sequence. So we'll go on to use our common difference formula, which is T2 minus T1, T3 minus T2. Our T2 is 3 minus a negative 1 is equals to a T3, a 7 minus a 3. This is a 3 plus 1 equals to a 7 minus 3. A 3 plus 1 will give us a 4. Also, a 7 minus 3 will also give us a 4. Therefore, we conclude our D is actually a 4. Now that we found our common difference is 4, which means that we are dealing with an arithmetic sequence, we'll then write down our arithmetic sequence sum formula. Then we know that since this is an arithmetic sequence, we'll then go back to our sum, knowing that we are given that the sum of this whole thing is 594. So our Sn is 594. So we are no longer looking for Sn, la sum of n terms, but you are looking for n, with what was n, in order for us to find the sum being 594. So where there is Sn, I'll substitute 594, and this is our unknown n that you're looking for. This is 2. Our a is the first term, being a minus 1, plus our n, we are looking for that n. Then our d is a 4. From here, you'll then solve for n. But firstly, you must go for our bracket inside. We must go for our bracket inside, which is what? 2 times 1, this is a negative 2. This is a plus a 4. 4 times n is 4n minus 4. Then from here, we have our n over 2, 594. Then these two are like terms, minus 2 minus 4. Then this is what we find when we multiply out these brackets inside. Then from here, okay, let's just write this clearly. This is our 4. From here, we'll have to multiply out. So you go on to say n over 2 times a 6. Let's just do that on the side, just so we can have enough space. This is our n over 2. Then inside the bracket, we have 4n minus a 6. Then you multiply out n over 2 times 4n. We'll get that n times 4n, top and top, this is over 1 over 1. Top and top, we get a 4n squared. 2 times a 1, it's a 2. Top and top, n times negative 6, we get a negative 6n. 2 times a 1 all over a 2. Then we still have our 594. Let's just position it well here. Then now, this is our 4 divided by a 2. We get a 2n, as much as this side is 6 divided by a 2, we get a 3n. So this one, you get a 2n squared. For this one, you get a negative 3n. And this is our 594. Then from here, we take our constant to the other side. We get a 2n squared minus 3n minus 594 equate this to a 0. You can then use a quadratic, or you find the factors that you will multiply. So to save time, you can use your quadratic. All over 2a. This is our quadratic, where we'll find our n. My b is a negative plus or minus. My b is a negative 3 squared minus 4. My a is a 2. My c negative 594 all over 2. My a is a 2. My n, it's a negative 33 all over a 2. Then you have to change your sign from a plus to a minus. Or your n, it's 18. Therefore, you draw up a conclusion that your n was actually 18. For you cannot have the number of terms being a negative. So this one, it's not applicable. This one is not applicable. Then we conclude that our n is actually an 18. We are now looking at the sigma under the geometric sequence. So we still follow the same procedure, where we are to firstly find the first 3 terms, which the first 3 terms are the ones to determine for us whether you are dealing with an AR or GS. So now we'll have to firstly substitute k here. K is 5 to get our term number 1. And if you substitute k is 5, we get a 3. And if we substitute our k as 6, we get a 6. If we substitute our k as a 7, we'll get a 12. Then from here, we will go on to use our common ratio formula, where we have a T2 all over a T1 is equals to a T3 all over a T2. Our T2 is a 6, our T1 is a 3, our T3 is a 12, our T2 is a 6. 6 divided by a 3, you get a 2. As much as a 12 divided by 6, you get a 2. Therefore, we conclude that our R is actually a 2. So now I know that I'm looking for a sum of a geometric sequence. Then I go on to write down the sum formula of a geometric. So my first term is a 3. My common ratio is a 2. Then before you go on to substitute your n, you must use the formula, same formula, the one we were using previously, where we will find our n using the top minus bottom plus 1 formula, where our top is a 12, bottom is a 5, so it's 12 minus 5 plus 1. Our answer, we get our n to be an 8. So now we are finding a sum of 8 terms. Where there is n, I'll have to put an 8 minus a 1 all over my common ratio 2 minus a 1. Then sum of 8 terms will give you, you'll then go on to substitute this on your calculator, punch it as it is. Together the sum of the 8 terms is 765. Then that's your answer. Yeah. Those first 3 terms, you find your T1, you find your T2, you find your T3. But now it says that start substituting K as 0. We'll put a 0 here. What do you get? When you put a 0, you find your T1 to be a 6. Then you put a 1. When you put a 1, you'll get your T2 as 18. Then you put a 2. Where is K? You put a 2. Get a 54 as your T3. Then now we go on to find our common ratio using the T2 over T1 also equals to a T3 all over a T2. My second term is 18, first term is 6, my third term is a 54 all over 18. Then 6, 12, 18, I get a 3. This side as well, I get a 3. Therefore, I conclude my R is equals to a 3. Then I go on to write my sum formula, A Rn minus 1, R minus a 1. Then I'll have to know I'm finding the sum of what? Using my formula. Let's put it here, that formula where we have our n given by top minus a bottom plus 1. This is our top minus bottom plus a 1. My top on my sigma is a 8, bottom is 0, so it's 8 minus 0 plus 1. I find my n to be a 9. So here I'm looking for the sum of 9 terms being equals to, the first term was a 6. A is my first term, it's a 6. Then my common ratio is a 3 to the 9 minus a 1. My common ratio is a 3 minus 1. Then the sum of 9 terms, it's 59,046. Now we have to find that what was n on our sum formula. That will give us 381. It was the sum of what that gave us 381. So we still have to go on to find the first three terms. This is our first term, second term, and third term. It says you must start to put k. Where there is k, you must start to put a 1. When you put a 1 there, you get your first term as a 3. Then you place a 2. What follows a 1 is a 2. Then you'll get your second term as a 6. Then you'll place your 3 where there's k. You'll get your third term as a 12. Then you go on to use the common ratio formula. My second term is a 6 divided by the first term. My third term is a 12 divided by second term. I get a 2. I still get a 2 here. Then I conclude that my R is actually a 2. Then I know that what I'm dealing with, it's a geometric sequence. So since the sum is given, sum formula, where now I need to find my n, meaning that my sum, since it's given there, this is my Sn. Where this Sn, I'll put a 381 is equals to, my first term is given as a 3. My common ratio is a 2. Then my R is a 2 minus a 1. You'll then have to do use your algebra to solve. Let's just draw a dividing line here. Okay, let's just use this part because we won't need that much of a space. We are continuing with to solve this n. I have a 381. I have a 381 is equals to a 3 to the 2n minus a 1 all over. This is a 2 minus 1, which is just a 1. Leave it as it is. Then from here, I'm solving for n. I divide both sides by 3. So it's 381 divided by 3. What I do on the left, I must do on my right. 2 to the n minus 1. I divide this side as well with a 3. This 3 will cancel. 381 divided by a 3, you get a 128 is equals to a 2 to the n minus a 1. So this is actually a 127. When you divide 381 by 3, you get a 127. Then from here, you take this one to the other side. It's 127 plus a 1 is equals to a 2 to the n, which is now 128 is equals to 2 to the n. Then from here, it's either you make your bases to be the same. Are you able to write a 2 to the power of a number? Then if you have your bases to be the same, you'll then drop your base. then take your exponents. So a 128 is a 2 to the 7, then this is a 2 to the n. I've made my base to be the same, then I drop the base, I remain with the 7 is equals to n. Therefore my n was equals to a 7. Then yeah, that's your answer. We now have to find the sum to infinity. As the question states, determine the sum to infinity of the following geometric sequence. We are given a 5 plus a 5 over 2 plus a 5 over 4. Then it continues. So we have to find the sum to infinity with knowing that our formula for the sum to infinity will have an a 1 minus r, and we have to take note that the sum to infinity only exists because of this condition that our common ratio is supposed to be between a -1 and a 1. So we are to use our given sequence now to find our common ratio. Let's just take it to the side where our r is given by a t2 all over a t1 equals to a t3 all over a t2. So our t2 is a 5 over 2 divided by a t1, which is our 5, equals to a t3, which is a 5 over 4 divided by a 5 over 2. Our answer, we get that this side is 1 over 2. Also, 5 over 4 divided by 5 over 2, you get a 1 over 2. Therefore, our r is equals to a 1 over 2. We go back to our sum, where we have to find the sum to infinity, knowing that our a is the first term. In this instance, it's a 5. 1 minus a 1 over 2. Then our sum to infinity for this sum in particular, we get it to be, you'll punch this on your calculator to get a 10. Determine the sum to infinity of the following. Looking at B now, we have sigma. We start to substitute x as 1 on our Tn formula. Also now, at the top here, we are finding the sum to infinity. So, before you go on to find the sum to infinity, you first have to find the first 3 terms, and your T1, T2, T3. My T1, when I put a 1 here, my answer, I'll get a 1. Then next up, where there is x, I'll put a 2. What follows after a 1 is a 2. You'll get your 1 over 2. Then on your x, you'll put a 3. And you'll get a 1 over 4. So, from here, we go on to find our common ratio. T2 all over T1 is equals to a T3 all over T2. T2, it's a 1 over 2 divided by 1. equal to a T3 1 over 4 divided by 1 over 2. A half divided by 1, you get the same thing, 1 over 2, as much as when you divide a 1 over 4 by 1 over 2, you get a 1 over 2. Therefore, our R is a 1 over 2. Then we add 2. Remember that you are finding the sum to infinity. My sum to infinity, this is the formula that I'll use, 1 minus R. Also bearing in mind that the condition for this is that R is supposed to be between -1. R is supposed to be between -1 and 1. Then my first term is a 1. Then 1 minus my R, it's a 1 over 2. Then my sum to infinity, you punch this on your calculator, you'll get a 2.